Let's determine if the lines produced by the given equations are parallel, perpendicular, or neither. Okay, keep in mind, we need to compare their slopes. So the slope of the first line is 5/3. The slope of the second line is -3/5. Okay, they are not the same, so this is not a pair of parallel lines. Okay, maybe they're perpendicular. Remember, to be perpendicular, they have to have opposite signs. Okay, so far we have that. We have a positive and a negative. And they have to be reciprocals of each other. Yes, 5/3 is the reciprocal of 3/5. Okay, so therefore we have perpendicular lines. Okay, so now let's solve the system. Let's figure out at what point do these two lines intersect each other. Okay, so we had, I want to say it was y is equal to 5/3x minus 3, and y was equal to -3/5x plus 19/5. Okay, let me check to make sure I wrote those down right. 5/3 x minus 3, -3/5 x plus 19/5. Okay, now to solve the system here, I need to recognize the fact that I'm looking for a point, in other words, a common x and y value. Okay, so if we're assuming that they're sharing a y value, then we can just set the two equations equal to each other and go from there. If I set the two equations equal to each other, I see that I have one equation with a single variable, x, that I'm looking for. Okay, so first thing I want to do is get rid of all of these fractions here. I have denominators of 3 and 5, so the common denominator would be 15. In other words, 3 and 5 both go into 15. Okay, so I'm going to multiply each term by 15. Let me give myself some space to do that. Okay, so I'm going to multiply every term by 15. That will eliminate all of my fractions. Okay, so remember, whenever you're multiplying a whole number or an integer by a fraction, you can divide by the denominator first and then multiply by the numerator. That actually works out better in this scenario here. 15 divided by 3 is 5. 5 times 5x would give me 25x. Okay, 15 times 3 is going to be 45. 15 times -3/5, well, divide 15 by 5, you get 3. 3 times -3x is -9x. 15 divided by 5 is 3. 19 times 3 is 57. Okay, so this is my new equation. Okay, easier numbers to work with. Let's get rid of the variable term on the right side. It's a -9x, so I'm going to add 9x to both sides. 25x plus 9x is 34x. Bring down the -45 equals 57. Okay, now let's eliminate the constant term on the left side. So I'm going to add 45 to both sides. That will eliminate the constant term, -45, from the left side. I'm left with 34x equals 57 plus 45, 102. Now let's divide both sides by 34. 34 divided by 34 is 1. So that's 1 times x, which of course is just x. X equals 102 divided by 34 is 3. So if I'm looking for a point, an x comma y ordered pair, that represents the solution to this system of equations, I have found that the x value that they share is 3. Now to find the y value, plug 3 into either of these equations. I'm going to plug it into the top one there because I know I'm going to plug a 3 in right here, and that 3 will cancel out with this 3 down here, right? So I'm kind of looking ahead to decide which one would be easier. Okay, so y equals 5/3 times x. We just said that the shared x is 3 minus 3. Okay, and just like we said a second ago, we have an integer multiplied times a fraction, so I can divide the integer by the denominator. In this case, they divide out and give me 1. 5 times 1, of course, is just 5. So this is really 5 minus 3. And 5 minus 3 is 2. So there's the ordered pair, 3, 2, representing the point at which these two lines intersect.